All right, so lecture 2, factoring polynomial expressions. In this lecture, we're going to go over two main ideas, how to factor or finding the common factor between two, like multiple polynomial expressions. And we're going to learn the technique how to factor a second degree polynomial of the form x squared plus bx plus c. Okay. So find common factors first, right? So again, this material you may have seen before. How many of you have seen common factor finding common factors before? Okay, very good. And also finding the factor of form x squared plus bx plus c. So again, I'm gonna spit off through the process, but if you think I'm going to fast, slow me down. Good. All right. So polynomial expressions on the first column. Let's try to find a common factor and rewrite the expression in the factor form. Okay. 2x plus 4, what is the common factor here? 2, right? What about 3x minus 6? It's very simple. So in the first example, 2x plus 4, the common factor is 2. In the factor form, you have 2 times x plus 2. For 3x minus 6, the common factor is 3. The factor form is 3 times x minus 2. Now, what about the third one? 2x squared minus 4x plus 8. What is the common factor here? 2 again, right? And the factor form is 2 times x squared minus 2x plus 4. What about x squared plus x? What is the common factor? X, yes. And you're left with x times x plus 1. The next one, x cubed minus 3x squared. What is the common factor? X squared, very good. So you get x squared times x minus 3. What about 6x squared plus 9x? What is the common factor here? 3x, right? 3x. And you get 3x times 2x plus 3. Any questions on this one? Any question on 6x squared plus 9x? Now, what about 2x to the fourth minus 6x cubed plus 4x squared? What is the common factor here? 2x squared. Okay. So you left 2x squared, and you left with x squared minus 3x plus 2. Okay, so far so good. Right, so if you notice that x squared minus 3x plus 2 can be factored further, but I'm going to wait. Just do the common factor for now. Okay. What about the next one? I'm not gonna say that. What is the common factor here? Yes. 2xy cubed. So the common factor is 2xy cubed. So 2xy cubed here. And you're left with 9x cubed y cubed minus 8 times x squared minus 6 times y. Any questions on this one? Right. Hopefully, when you write down something from the notes, you understand what it means. Okay, don't just blindly copy it there. Okay. Okay, if you have any questions, let me know. If you're a little bit shy, you don't want to ask questions, again, you can rewatch the video later. Okay, you can email me if you have any questions. All right, what about the last one? Yes. X
cube. Yeah, x cube what? Yeah, yeah. Yeah, we get x cube y, right? Good. X cube y. And you're left with what? Y plus 3x plus 5x squared y squared.
Cool. Any questions? All right. So that's basically how you find common factor. So I'm gonna do a little more complicated examples. Um, the common factor can be one term, can be multiple terms. Yeah. So between these two terms, what is the common factor? Yeah, so x squared plus 2 is the common factor in this case.
So x squared plus 2 is the common factor. X squared plus 2 is the common factor. So you factor it out and you're left with x plus 3. Now, does it make sense to you?
Good.
Okay. What about the next one? 2x times 2x plus 5
Plus 2x squared, what is the common factor?
2x is the common factor. So 2x here, 2x here. Yeah, so you get 2x as the common factor, and you're left with 2x plus 5 for the first term, and then plus x for the second term.
So just try to simplify as much as you can. So inside the parentheses here, you can combine like terms. So 2x plus x, 3x.
That's the answer. What about the next one?
What about C? What is the common factor? Somebody in the back. 4x minus 3. So 4x minus 3 is the common factor.
Take out 4x minus 3, and you're left with 4x minus 3 plus 6x. Okay. Now simplify as much as you can, especially in the second parentheses. You combine like terms. You get 4x minus 3 times 10x minus 3.
Question? Yep. All right. What about D? What is the common factor here? X minus 1 and x plus 2. Yes. Technically, yes. Right. But we need more than that, right? You also compare the power. So x minus 1 squared. What about x plus 2? 2 cubed.
So here I'm going to use two different colors for each factor. Okay, so x minus 1 square and x minus 2 cube. So you have x minus 1 square times x plus 2 cube, and you're left with 3 times x plus 2 plus 4 times x minus 1.
These two terms right here, the common factor. Inside this parentheses, what you have left, you have to take it out of factor.
Any questions? Questions. All right, so let's try to simplify the expression inside the last parentheses. So I'm gonna distribute 3 into the parentheses and 4 into the parentheses here. So I got 3x plus 6 plus 4x minus 4. Finally, the result is this 7x plus 2 for the last parenthesis. Now for E, I'm gonna give you like 30 seconds to work through the problem. One, but everyone's did very well. All right, so the common factor in this case, bear with me here. Some of you got the right answer into the end, but bear with me here. So the common factor is compare the constant between the two expressions. So the two is the common factor. Some of you did not take the 2 as the common factor at the end, but toward the final answer, you still got it right. That is okay. Okay. But I want to cover all the bases. So 4 and 2, so 2 is the common factor. X plus 5 to the third power and x plus 5 to the fourth. So the common factor is x plus 5 to the third power. Got it? And x minus 1 square with x minus 1. So x minus 1 is the factor. So 2 times x plus 5 cube times x minus 1. And you're left with 2 times x minus 1 plus x plus 5. So again, some of you did not take the 2 as the common factor at the end, but you still got the right answer. That is okay. So this can be written as 2 times x to the fifth power, plus 5 to the third times x minus 1 times 2x minus 2 plus x plus 5. Now you simplify the parentheses here, and you combine like term, you get 3x plus 3. And for the last parentheses, you can factor further. So 3 is the common factor. You with me? So you take out the 3, multiply with 2, so you get 6. It's the common factor. So 6 times x plus 5 cube times x minus 1 times x plus 1. Are we cool? Yes. All right. So the reason that we learn how to simplify or how to factor things in expressions not only allow you to do cancellation or reduction later on when you get to rational expressions, but also when you think about everyday life situations, we don't have just one data point. You have million and probably billion of data points. Okay. And then if you have those data points, you plug into this type of expressions, there's a lot of calculation in between. You with me on that? All right. So therefore, when you simplify things down and factor things out, the calculation reduce a lot. You with me on that? Okay. And also with the power of the computers, with the machine that we have,
we can do parallel computing, right? So you can send the this information x plus 5q to one computer or to one machine to do the calculations, x minus 1 to another machine, and x plus 1 to do it like that. So there are technically a lot of usefulness in learning consistent expressions. Okay, any questions? Okay, let's move on to another expression, x squared plus bx plus c. So if we have this form, can you actually simplify or apply a factor form of x squared plus bx plus c? So technically what you're trying to do is to find two numbers, little a and little b. So find a and b such that when you add these two numbers together, you get capital B. And when you multiply these two numbers together, you get capital C. And if you can't find these two numbers, little a and little b, the expression x squared plus capital Bx plus capital C can be written as x plus a times x plus little b. So that's the theory behind it. Any questions? All right. So in example 3, can you fully factor the following expressions? Let's start with x squared plus 5x plus 6. Again, you're looking for two numbers, a and b, such that when you add them together, you get 5. When you multiply them together, you get positive 6. And 2. Some of you know it. So positive 3 and positive 2. So you do x plus 3 times x plus 2. Again, because y3 and 2, you add 3 and 2, you get positive 5. Multiply 3 and 2, you get positive 6. That's the results. Any questions? What about b, x squared minus ax plus 12? Again, you look for two numbers. When they add them together, you get negative 8. When you multiply them together, you get positive 12. Negative 6 and negative 2. Very good. So therefore, you write x minus 6 times x minus 2. Again, let me write down a quick explanations, because when you put negative 6 minus 2, you get negative 8. And when you do negative 6 times negative 2, you get positive 12. C, x squared minus 3x minus 10. Positive 2, negative 5. Positive 2, negative 5. Yes. You get positive, sorry. Good. Now for D, before you can apply the technique we just learned, we have to find a common factor first. Okay. So x to the 4th minus 9 times x squared. So x squared is the common factor now. And you're left with x squared minus 9. Are we okay up to this point? Yes? You know where it's coming from? So you may recognize that x squared minus 9 is a difference of 2 squared. You can apply that. Or you can apply what we just learned. Okay. So let's apply what we just learned. So x squared plus capital Bx plus capital C. What is capital B
equal to, in this case, 0 in this case, right? And C is -9. So you look for two numbers. When you add them together, you get 0. And when you multiply them together, you get -9. You with me on that? So what are the two numbers? There you go. Right. So there's another way to this problem, right? Another approach to solve this problem. Good. So now you have EF, GHIJKL, right? So you have that many problems. Can you work on those problems? You can work by yourself and work with your little friends. Two. Right. Me and Madeline gonna walk around and talk with you, okay? Good. Let me know. Let us know if you have any questions. Okay. I'm gonna give you like 30 seconds for a head start. Okay, good. So for L, before we can apply x squared plus bx plus c formula, what we do is we find a common factor. So between x squared minus 2x cubed plus x to the fourth, x squared is the common factor. You with me on that? All right. So that's not the problem. The problem is when you take out the x squared in the first term, you actually left with 1. Okay. So x squared here means that 1 times x squared. Okay. So let me actually rewrite the expressions. So you have 1 times x squared minus 2x cubed plus x to the fourth. So when you take out x squared or find x squared as the common factor, you're left with 1 minus 2x plus x squared. You okay with this step? All right. Now remember from the last lecture, I mentioned about polynomial expression. The conventional way to write the expressions is starting with the highest power. We go down to. So let's rewrite these expressions, starting with x squared. So you have x squared minus 2x plus 1. So with this form, it looks like it's similar to what we have right here, x squared plus bx plus c. Again, you look for two numbers. When you add them together, you get -2. When you multiply them together, you get +1. So the two numbers are -1, -1, right? So you have x squared times x minus 1 times x minus 1. Now, if you notice that you have the same x minus 1 times x minus 1, so I'm going to do x minus 1. Good. So the result should be x squared times x minus 1 altogether square. Question? Concern? Comments? All right. So I think we cover everyone in class. Did I miss anybody? All right. So even though I didn't go over everything, I will post the solution to lecture 2 on Blackboard. So if you have any questions, you can go back. Okay. We still have plenty of time, so we're gonna start lecture 3 today. Any questions? All right. So as I mentioned earlier, you can with polynomial expression, you can do addition, subtraction, multiplication, and you can do division as well. Okay, so that's the motivation for rational expression.